If the universe is infinite, then it'll always get bigger and we'll never be able to fully measure it. But even if that's the case, we can still measure the observable universe, everything we can see or comprehend. Because light travels at a fixed speed, we can estimate just how big the area is that holds all the galaxies and stars we know about from Earth. The universe is 13.8 billion years old, but taking other factors into account, such as the amount of expansion that's occurred over time, we can calculate that the edge of the observable universe is actually 47 billion light-years from Earth. It's thought to be about 93 billion light-years across in total. We, on Earth, aren't truly at the center of the universe, of course, but expansion does make it seem that way. Unfortunately for today's question, though, all of this knowledge doesn't tell us much about the rest of the universe, the unobservable parts, everything that we can't see. So what else does an infinite universe mean? For one, there's no such thing as an edge to it. Space continues on forever, without end. Not only that, but according to some interpretations, it could mean that there are infinite galaxies and stars as well, and infinite variations in how they're structured. In theory, if you were able to travel through an infinite universe, you would eventually come across a star that's exactly the same as our own sun, plus another that's similar minus one small adjustment, and another that's just as similar, just with another minor difference. More interestingly, you'd eventually come across another Earth, with even another you living on it. In fact, because there would be no limits to the number of potential variations, one understanding of an infinite universe even argues that there could be an infinite number of yous out there in space, existing in much the same way as you currently do, on similar or identical planets in similar or identical star systems. But where exactly would all of this extra matter come from? Well, naturally, there's no conclusive explanation for such an outlandish theory, but one potential answer is that there wasn't just one Big Bang at the beginning of creation, but instead there were multiple bangs at multiple points across an apparently endless plane, our universe. But back to the matter at hand. A finite universe, one that doesn't go on forever and does eventually end, is perhaps a slightly less mind-boggling concept, but it still has its own set of significant ramifications. Say it was proven that the universe was limited. Now it could also be measured, and we'd finally have a surer idea on how big it really is. In some ways, we've already made strides toward this figure, regardless of whether the universe is or isn't infinite. According to the theoretical astrophysicist Ethan Siegel, writing for Forbes in 2017, by analyzing cosmic microwave background radiation left over from the Big Bang, we can say that the whole universe needs to be at least 15 million times as big as the observable part we know about, which is 11 trillion light-years in every direction from Earth. Because it's also thought that the universe underwent a period of cosmic inflation before the Big Bang even occurred, Siegel also suggests that it's probably much bigger than even that. 11 trillion light-years is the lower estimate. If it actually ended at that point, though, it would be enormous but still finite. So do we have any idea on what that end would look like? Even if the universe were found to be finite, it wouldn't necessarily need to have an edge, the existence of which depends entirely on what shape the universe takes. If it's shaped like a disk, then it does have an edge, but astronomers are increasingly uncomfortable with this idea. Spaces with edges can be hard to justify theoretically, and an edge of the universe, something you could fall off of like the edge of a table, is something we can't really imagine. That said, most scientists agree that, given how light travels, the universe is likely flat, in a manner of speaking. But therein lies the problem, as we now have an inconceivably large something that, for today's question, is potentially flat, finite, and doesn't have an edge. The three criteria don't seem to fit together. Mathematics does provide some solutions, however. A Mobius strip, for example, can be flat and finite. It endlessly loops, continuously flowing into itself. Another theory is that the universe is built like a donut, called a torus, an idea which was expanded on in the 1980s by a team of Russian scientists who proposed that it was actually a three-torus, a similar structure but with an added dimension. And then there's the idea that the universe could take the shape of something called a Klein bottle, a strange tubular structure first put forward in the 1880s, which would also allow the universe to be flat, finite, and without an edge. Right now, there's no way of knowing if any of these shapes is or could be the right one, but there are at least some options. The shape of the universe could affect more than just our own understanding of it, though. It could also dictate our chances of encountering other life. If the universe is infinite, then there is almost certainly other life somewhere. The only conceivable way that Earth harbors the only life in an infinite universe is if the chances of life forming, of any life forming, are literally infinitesimal. However, an infinite universe may also mean that instances of life are separated by vast, physically unachievable distances, meaning that we'll never know about them no matter how advanced we become. If our universe is finite and exists as a closed and measurable system, however, then there's arguably a much greater chance that we will one day be able to make contact with other life, if it exists, whether physically or through transmissions. Though the distances we'd be dealing with would still be vast in a finite universe, they wouldn't be infinitely vast, a fact which in itself makes them much more manageable. This would be especially true if the universe, for whatever reason, doesn't continue to expand as it currently is doing, but instead begins to contract. In that especially hypothetical scenario, there'd be a point where galaxies move close enough together that communication between them would become much more feasible. Universal contraction isn't necessarily the fate of the universe. There are various possibilities for that, but if it is finite, then it will end in some way. Whether all matter is crushed via the Big Crunch or it expands itself into oblivion through the Big Rip, a finite universe means there will be a final moment. While other theories like the Big Bounce allow for some degree of universal rebirth, pitching the universe as though it's one part of some kind of higher, grander cycle, this wouldn't be an option if space was actually capped. Yes, we could one day measure it and understand it in its entirety. Yes, that could mean a greater chance of discovering life elsewhere, but it would also mean that in the very distant future, our days of discovery would ultimately be numbered. For now, we can't be truly sure one way or the other. Maybe the universe has an end, maybe it doesn't. But that's what would happen if the universe wasn't infinite.